welcome to our YouTube channel. So, today we are having a very special guest with us, the founder of India's fastest growing semiconductor foundry. So, this young company is making waves in the industry, and today we will explore their journey and opportunities in the VLSI landscape for students and entrepreneurs. So let's dive deep and hear how this incredible growth story began. Let us start with what are the some key areas within VLSI that students should focus on to build a strong foundation?
So there are multiple ones. If you start with RTL design, that would be the great way to start. Then you can also work on verification. You can also work on DFT. You can also work on SOC level. You can also work on memory as well. Uh, but I guess the industry is changing every day, so you also need to keep track on multiple technologies as well. Uh, but you can start with some basic RTL that would help you understand this whole one. And I also suggest doing some projects with some teams as a team member. So that is the main part.
So should we do RTL first or digital circuit design basics first?
Digital circuit design would be first, then you
Yes.
come to RTL. But when you do digital circuit design, your focus should be that sooner or later in near future you want to enter into RTL. So that's how you should start learning uh, the digital designs. And if you look at the materials and courses available in Coursera or Udemy, they are really good.
Yes, very true. So, with the rapid pace of technology, how can students and young professionals keep up with the semiconductor trends and VLSI?
Best part would be collaborating with small teams. Be associated yourself with lot of events and symposium happening. Lot of education institute as well as large chip design conglomerates like AN for Chip, Texas Instruments, NVIDIA do a lot of activities online as well as offline on regular basis. I strongly suggest that you also participate on offline events as well. Over there, you get a lot of insight. You get what's happening under the table, under the radar, and you also get insight on what other students are doing as well. I also suggest following activities and news of lot of VLSI companies as well. That will also give you some insight where the trend is moving towards.
Yes. So, like Monk also conducts some offline workshops, right? So, would
Right.
you like to tell about that?
So basically, we started this in 2021, where we started teaching, students from starting with very basic knowledge, starting from what type of transistors are there, starting how MOSFETs are being fabricated and being used in design, then moving towards CMOS devices. Then we also teach them how to start your RTL coding, what tools you should use. We are part of open source community where you can utilize open source EDA tools and complete your RTL to GDS without getting any license or everything. So anyone from at any stage, even I have seen some students at completing that 12th standard started designing some chips. So we do this
Yes.
as a boot camp where we have a 12 to 15-day program where we do 12-day training and 3-day live hands-on. And then once that is done, uh, we find best students, and we uh, uh, participate their design in some good programs where their work has been sponsored, or scholarship has been applied.
Yeah, hi. Hi. This is
Yes.
Ramakrishnan.
Yes.
Yeah. So my question is, so right now I don't know exactly what is that meeting agenda, but my question is, for example, if unknown IP, like for example, PCI or DDR or anything, any AP. So how to validate that futures, particular futures, we don't have any RTL codes on it, we don't have. So how you grab that resource and how to verify that IP or SOC level. So there is so many types, right? Like for example, SOC level we are used for C base verification, some internal integrations works, and functionality like code coverage, functional coverage, and toggle coverage, so many scenarios to verify, right? So what are the procedure to follow that first steps? What is the first steps? What is the end steps? You know anything?
So basically, for verification, I suggest that you participate in a team-based learning. Gather a small team. Some one would be using the high-end tools. Some of you can utilize the C++ based verification. Some of you can utilize some of the cloud verification system have been provided by a lot of institutions. Second thing, you need to read a lot of research paper based on the technology you're working on. So in research gates, there are some research paper published, particularly how to testify your RTL, which is for first time. So there are some techniques available on that, and you can utilize those techniques, and you can start putting that in action.
Yes. So, what do you think are the biggest challenges and opportunities in the semiconductor industry today?
So there are multiple, ways you can build your career in semiconductor these days. If you look at the Indian scenario, there are a lot of companies already being, started their operations. They have already started recruiting, particularly large fabs, which we are talking about, like Tata Osset or Tata Fab, and then CG Power Semiconductor, then Micron. So basically, you can go for a basic circuit design to RTL design. Then you can be part of the ASIC team. You can be part of DFT. You can be part of verification team. That is only for design. You can also learn fabrication these days. A lot of resources and courses available. There are a lot of support available from different institutions like IISc Bangalore and IIT Madras. Even IIT Guwahati is doing really nice in terms of fabrication. So you can also learn fabrication. And you're also you can learn the backend process, which is like post silicon validation, marking and testing, which requires huge employment is being generated as we speak in OSAT and ATMP plants as well, and a lot of resources and training available for that as well. So in general, there are multiple doors are open for this kind of opportunities these days in India. And particularly, if I also suggest that even if you're going in chip design, but you should learn a little bit of chip fabrication and backend process as well. If you're going for a chip manufacturing or fabrication area, you need to understand the basics of design as well. So you can be a master of one, but you need to learn other areas as well.
Like the technology of the technology, we should have depth in one skill and have a basic knowledge of all the different kinds of skills, right?
That.
Okay. And yes, I came across a nanofabrication course on Coursera also. That is also a resource which I found from my side. So, what are the challenges in semiconductor industry? Would you like to talk on that?
So the biggest challenge right now is in terms of fabrication and manufacturing. If you look at the design part, India has been a really good, a market for chip design companies. As a rough estimate, 75% of world chips are being designed by Indians, whether in India or being an NRI. They design the chips we use. So chip design is already a very large market in India. It also started because of our growth in IT and ITES in like last 3 decades. But the challenges are there in semiconductor manufacturing because we do not have that talent pool available easily. And as I told you, like a lot of trainings are going on, but everyone want to go to IT or software related
Very true.
stuff. Everyone wanted to build a AI agent, but don't nobody want to build a AI chip. So that is the thing. Like people are not joining that. So that is manpower is also a problem. Even there are a lot of shortage for equipment engineers and process engineers who understand the process of semiconductor manufacturing. So these are the areas which requires some training, but there are huge potentials available to build your career into.
So, how is the hiring scenario in VLSI industry? Because many people say that there are no job opportunities in VLSI, and on the other side, we are seeing news coming up that we need 3 lakh engineers till 2025. We get to see so many such news, but still students saying no job opportunities. So, what are your views on this?
So basically, Indian students' mindset is quite different from the global perspective. We When we see that someone say that I am, RTL coder, then he completely focus only on one thing. As I told you, like you need to have explore some other areas as well. So when we see that we have these 300,000 new jobs opening, we need to learn few more things. I'm not saying all of them, but at least few more things which definitely will give you a career boost at uh, uh, only code. No, I didn't understand what he said. So basically you require to understand the overall electronics market as well. So whenever I visit any new chip design company, even the chip startups are recruiting heavily in Bangalore, Pune, even in Gurgaon as well. Hyderabad is also hiring a lot of chip design things. Looking towards the number of engineers passing every year, the job opening might be not sufficient to give opportunity to everyone. But if you work hard and if you focus, then definitely you get a really good path for your career.
Like
So
for a design engineer, he should have knowledge in verification also, right?
right, exactly. When you know some bit of verification, you work on your design project accordingly, and that help you to build really good projects, and your overall project management becomes smoother.
Hello, sir.
Hello.
In the analog domain, layout design and the RTL design and verification, which domain could be a more demanding and growth in the learning perspective also?
Another very good question. Everyone is focusing on digital, but there is a huge demand for analog and mixed signal. So if you learn analog and mixed signal, there are a lot of analog SOCs are coming up. Even mixed signal SOCs were previously there, but there is a huge demand started for analog SoCs. So that is itself a huge market. Companies like Aero, companies like Texas Instruments require huge amount of talent, particularly in analog as well. If you look at the quantum development, the analog is going to be a really game changing chip design industry. Again, if you look at neuromorphic computing in memory, computing is also there, but analog itself has really good potential. Thank you, Gangadhar.
So it may be like analog circuit design and analog layout design. So analog layout demanding learning perspective the and the perspective of RTL design and verification. So I see. I heard that there will be a lot of growth opportunities in RTL design and verification compared to analog layout. What is your views?
You're absolutely right. Yes, if you look at that way, analog layout would have, lot many opportunities coming up. And if you see, if you're following a lot of companies in LinkedIn, you'll see a lot of new projects have been started. These projects require like 25 to 30 engineers work on a single project. So yeah, in a way, you're right.
And
Okay,
what,
thank.
like, we are hearing that this is the era of chiplets. We are moving from SoC to chiplets. So, what would you like to say on that?
So basically, even in a chiplets, these are like kind of a system on chip itself, right? So we are moving not from SoC to chiplets, we are moving from bigger SoC to smaller SoCs, where initially we used to make a lot of peripherals and everything inside one chiplet, and then the requirement moved to application specific ICs. So for that, we require to create smaller applications where we have modules which is required at at highest priority. So these chiplets have the small targets, and even the foundries are supporting these chiplets. Yeah, can you repeat your question, Lokesh?
You can open your mic also.
So, good evening, sir. That my
Good
question is
evening.
most of the things that we learn in the things like only in projects only, but actual reasons that we are implementing only in the job role only, sir.
That is true. Of course, it's a good question again, Lokesh, because we need to understand the user perspective as well. What type of chips are required? What type of applications are required? Based on that, we should select our projects and started working on that. For that, we need to keep track on a lot of product developers as well. So if you are connected with product developers, they will explain you what they require in their chip, and based on that, you focus on those areas instead of only just focusing on jobs. I have seen a lot of RTL designers and students just completing their engineering, join a startup, or starting their own IP based startups. So even the IP based startups are really good concept, where you and your team develop a lot of IPs, and share a revenue with people who utilize your IP. That is a really nice way to start your career as well. And that way you can learn lot many things instead of doing the job, where because in job you have fixed KRAs and a very short description that you have to do only this and this. And then when you work with a startup, you have multiple profiles, and you have to learn lot many things compared to a regular job profile. Yeah.
Okay. Any questions? Should I go on? So, Can you share now, as you are a founder of Monk 9 Tech, so can you share your journey of founding a semiconductor foundry and what inspired to enter this field?
So basically, in 2014 and 15, I have been working on a project where I required to deploy some application-specific logic, and I was not able. I was working as a chief technical officer in a company, and I also required to, source some of the chips which were not available. So at that time, we thought that FPGA deployment would work, and we deployed FPGA and we successfully completed the application. But then I realized that why there are no market for ASICs in India, because then I realized that the whole market has been captured and monopolized by a company called iMac, which is providing the Euro practice access to foundries. So a lot of foundries charge very high to Indian institutions and startups. Just to get started at 130 or 180 nanometer, you will require $30,000 to $40,000 for licensing it, and then additional 25 to $30,000 to take out your chips, and you get only 50 prototypes. Once your 50 prototypes are ready, then you uh, uh, move into the production. So that was lacking in Indian market. Also, we didn't had any semiconductor manufacturing facility available for commercial projects. SCL Mohali is there, but they were like research projects and doing some projects with DRDO and ISRO. So I started gathering all the necessary points required to build a fab, build a team, build a process, involving experts. And I also joined eFabless Corporation, where they helped me understand the open source market. I started promoting open source tools, and eventually, by teaching open source tool, I also learn a lot of things in semiconductor as well. There is one question in chat. Yeah, it's Gangadhar. We see that job roles should have at least 3 years of experience. Freshers don't have opportunity. Why so? So it's not like that the fresher doesn't have opportunity. It's like a very basic thing of job perspective. We cannot give any medical students operate on a patient. Otherwise, patient will die. For that, you need to do some internship. So even doctors and advocates and chartered accountants do internship. So become a DV or experience verification engineer. You need to associate yourself with some internship or some live projects working on some companies. That way you get the gist of the process, how the things work, what kind of challenges are there, how you overcome the challenge, and how you develop that insight, that perspective to become a problem solver. So for that, you require to associate yourself with a live project before you actually jump into those kind of job profile. There's one more question by Jubin. First, Spandan asked, like, does work experience in the IT industry help any way for MTech in core domain in VLSI and embedded? Absolutely, it will work. Your, skill of developing a software, your ability to understand the, software development process, your ability to code will also help you to, design circuits. You can learn VLSI very easily if you're really good, your base and your concepts are very clear in IT, then you can easily jump into VLSI as well.
Yes, I would also add to that. So presently I'm doing internship at Go Verify, a verification company. So there I got to learn that verification is basically 80% software and 20% hardware. So 80% software is also very important and 20% hardware also can't be ignored. So In that you need some system design software, system design principles you need to know, and agile programming also. So yes, experience in IT helps in VLSI also. Like you must have strong coding skill. Like if you have strong coding skills, then you will easily adapt to RTL constructs also, right?
That's true. Jubel asked that what key skills required or projects to make a candidate stand out in internship in design and verification. I think the main skill which required doesn't require any specific industry. You need to have a task management skill and time management skill. Second thing you will require is the exposure of different EDA tools. You will also require to understand types of projects, what kind of projects it has, what kind of applications it has, and you also require to understand the fault management, and you also need to understand a little bit of some soft skills as well, and also problem solving ability. So basically some of these skills are not industry specific, but you do require them to stand out. And again, the best skill is like hard working. If we see, I tell you about myself, I'm not a genius, so I have only one way is hard work, hard work, hard work. So that way you
Yes.
can achieve all the skills you require.
So let us now talk about some business side also. So for students curious about the business side of things, can you walk us through what it takes to set up and run a semiconductor foundry?
It will require first a lot of problem solving ability, because semiconductor industry, of course, it's a very old industry, started in 1950s as well. But you need to understand that this will require a lot of collaboration. You cannot do it alone. You will also require a lot of experts advice. You will also require to a lot of funds and a lot of collaboration with bigger companies where you get a lot of support. So foundry business is what you should associate yourself with companies first, and then move to studying on your own. But on like VLSI part, student can start a lot of different companies. Like you can start an IP company where you create your IP. You can also start a verification company where you do the work for some design company. You can also start an education company where you teach VLSI and different things. And also you can do a different kind of a product company where you create your own SoCs and sell the chips itself. So all of them are really good business. Of course, Foundry is also a good business, but Foundry will require a lot of experience and association with a lot of projects and collaborations before you actually jump into that.
So would you like to talk something on tiny tape out, because in that also we do a chip tape out.
So Tiny Tapeout is a really good concept started by Matt Van in association with eFabless Corporation. So the Chief Technical Officer of eFabless Corporation, Mohammed Qasim, started this concept that a semiconductor should be accessible to anyone, and the goal was to anyone can make their own chip. So they went to Google, and Google provided funded the Skywater Technology Foundry to make Sky 130 PDK open source. So if you search for Sky 130 PDK, you'll find each and everything available for that PDK. Everything is open source. Then they moved to Open Road and created a one EDA tool, which is called OpenLane, which is RTL to GDS. So you put your RTL, you associate your template called Caravel, where you already have a RISC-V core and you have a management core, and you just have to put your RTL in a empty space, and your whole RTL to GDS flow is completed, and you give this GDS to Skywater Foundry, and you get a small chip of 100 pieces, and you can test them. You can create firmware, and you can also do embedded work. So overall whole ecosystem from idea to silicon, and silicon to embedded, everything is open source. And Google initially sponsored a lot of shuttles, so more than 650 projects being taped out, where students and institutions and some student groups and some engineers groups and some startups submitted their projects, and they get free microchip of their own design using this program. Then Google stopped funding the project due to budget constraints. So tiny tape out concept came with a very nice ability to give access to anyone. So the whole project is costing around like $10,000. But if you want your small design to be put inside a chip, and for that you don't have to pay too much, like you can pay up to $80 to $300, and you get one single chip with your own design on it, and you just have to run the open lane RTL to GDS flow, and submit in tiny tape out, and with only $300 you get your own ASIC. It would be, of course, the shared ASIC, where like some other projects are there, but you will get your own ASIC very cheap and very easily.
So, so Global Foundries also had some shuttle program, right?
Yeah, so basically there are two type of shuttles. One is the shuttle where you have the multi-project wafer, and there is some shuttle like we do it in Chip Ignite or Tiny Tapeout, where we collaborate all the projects and put it in single wafer. So that way you get really cheap way to get your microchips fabricated.
Yes. So as we are seeing these days, Intel is also doing a lot of layoffs. What? So many of them might be thinking of having a startup because not of getting jobs. So what are the most significant barriers to entry for starting a business in semiconductors, and how can aspiring entrepreneurs overcome them?
So initially, you should start with IP designing. That because that doesn't require too much, investment. You just need, uh, you know, uh, a laptop. And for FPGA, there are AWS Cloud FPGAs available, where you test your IPs on FPGA on cloud. So you can start with
Yes.
that. It will, reduce the barrier of having funds. Second thing is like there are a lot of supports available, like chip to startup by government. Then there is one more initiative called Vega processor by CDAC. Then there are like design link incentives, which is available by government. Lot of venture capitalists, incubators, and also like startup supporting entities support uh, a lot of chip design startup as well. They give funding from 7 lakh to 15 lakh to 20 lakh, just to get started on your ideas. So the barrier was the funds initially, because we have a lot of talents. Only we require is funds. So for that, a lot of funds are available. I think Zubair has asked some question. What do you think about government recent collaboration and investment? Is it any changes? Do you find any changes? I found really big changes, because they are hiring in thousands. So Tata is also hiring, CG Power, Micron, a lot many others companies are coming up. They are hiring in thousands. So they are making huge changes. The if actual effect will be seen in upcoming years, but the impact has already started.
Yeah, like a few days back, like yesterday only, I saw that government was calling people to work on ASIC designs for BLDC motors. So there are a lot of opportunities in IP design also. And what do you think? What about RISC-V IPs, RISC-V SoCs? Any,
It is one of the fastest growing trends right now in the industry. ARM is not accessible to anyone. Though ARM owns 100% of market share, whether you go for Apple or Android, ARM is have covered all the market, but still it like the small companies and emerging startups doesn't have access to ARM because of its cost. RISC-V is the only option. RISC-V recently has gone mainstream. A lot of laptops in China have been launched using RISC-V. Even the smartphones are coming for RISC-V. There are open source cores available for RISC-V, which will you can utilize it in FPGA or make your own ASIC using it, and you can run Zephyr OS or basic Linux kernel or maybe Android in future as well. So RISC-V is becoming a mainstream core as well. It has huge potential. You can also utilize the RISC-V to create your own, SoCs or neural processing unit, or you can utilize their own, instruction for convolution neural network or deep neural network. So yeah, it's a kind of a thing moving really fast and really nicely. Yeah.
Okay. So, what emerging technologies in semiconductor space excite you the most, and where do you see significant growth opportunities in next 5 to 10 years?
The next 5 to 10 years would be focused on battery-less applications. So you might require to start learning for SF7, which is 7 nanometer, or maybe
Yes.
PDK3, free PDK3 by education group in USA. So they have provided some basic predictive standard cells for 3 nanometer as well. So the future would be applications having 3 nanometer technology, which doesn't require battery. They will work on very low power delivery system, the interconnects. These are really challenging thing to improve the performance. So there are really good future for that. In upcoming years, I also see really good future on photonics as a interconnect and the data transfer as well. A lot of things are also working on data encryption, as well as the of course creating custom algorithm for AI. So we already use a lot of algorithms which are widely available. You create some chips using CNN, DNN. You create your NPU using such components, but using custom algorithms in creating AI chips are also emerging these days. Also,
Yes.
application specific, SoC are really a nice way to go into that, because like things are moving towards, for example, drones is a big industry coming up, and for that you will require like really nice PWM, ADC, and DEX. So these things really require.
Yes. So I heard some students discussing that AI will eat our jobs, even design jobs will be eaten by AI. So what do you think? What effect will AI put on VLSI?
So when I was a kid 30 years back, I used to heard that computers will come and computers will take away the jobs of all the
Yes.
accounting and engineers. So 30 years back, engineers used to do all the calculations on paper or utilize a calculator, and very few applications were available for computers. After once the computer came, we built the IT industry, right? So it doesn't have taken away the job, it has just changed the job descriptions. So if
Yes.
you look at the AI won't take our jobs, it will improve our life, and the job description will change. You don't have there won't be coders, there would be just code monitors, and the AI prompt engineers who prompt the computer to write proper codes. The circuit design and the RTL design will also done by AI, but you need to have that skills to operate artificial intelligence properly. The way we as a human learn from basic manual calculation to computational calculations, we will move towards the handing over our laborers work to artificial intelligence, and we will be just monitoring. So a new industry will emerge and the jobs will be converted. So if you stick to your job and you stop learning things, then definitely AI is
Yes,
deadly
very
for you.
true. If we will not learn AI, then AI will replace us, right?
Okay. Yeah, one more question is there. As a student aspiring excel in design and verification, what strategies you recommend for staying focused, effectively balancing the learning new concept with hands-on practice? So this is a very important question. Even Anushka will, relate to that, because she did like some internship even in Dassault. She did really nice, work with us in Monk as well. So uh, uh, of course hands-on practice is the best thing, right? And also have an insight of what's happening. You need to connected with all new things regularly. Even the new things have been emerging, you at least do hello world project with them at least once, right? Maybe
Yes,
you don't deep dive into it, but do connected with them. So that will increase your focus. Second thing is, try to connect with a lot of experts in particularly your interest base, and try to communicate with them what they are doing. Some of the people would are very nice. They give you very good insight. They will also point you to right direction, what you should read, what you should learn, everything. So I guess you utilize the use of LinkedIn completely, and maybe you can ask your teachers or maybe parents to get you a LinkedIn professional, the premium version as well. So being a student, you might not have that pocket money to get the LinkedIn premium, but you can ask your uh, you know guardians to understand that why LinkedIn is important for you. So utilize that completely.
yes. So, I would like to jump to this question also on networking. So, how important is networking in semiconductor industry, and what are the some best ways for students and young entrepreneurs to build meaningful connections?
So basically, not in only in semiconductor, including semiconductor, all other industry require a really good collaboration to, do the joint effort. Collaborative knowledge is the best knowledge. If you work on idea, but you are not collaborated, you're isolated, then there is a chance that you end up in a lot of issues which you cannot solve. So better to have great minds involved in your ideas as well. So networking is really important. I got my a good support using networks. I was connected to really great minds available in the industry using networking. I try to understand their thought process, try to understand what they are reading, what they are focused on, what their thought process are all about. Um, you can also learn from someone else mistake. You can through networking and through a lot of discussion with uh, your people with similar interest, you can get the gist of what you can do, where you can put your own full efforts. And you can also of course you can utilize your network to get early feedbacks. For example, if Anushka is starting some new startup, she can initially share her idea into small group and get honest feedback. And using that honest feedback, she can improvise her idea, and then put the idea very much ready to deployable. So the networking is really important in many cases.
Yes.
This is one of them.
So, so how can students leverage internship, project, or research opportunities to gain a competitive edge in semiconductor space?
There are tons of new internship as well as learning opportunities are available. Do open yourself to join startups as well. So a lot of students say we only want to join bigger companies, we don't want to join startup. That is a big mistake, because startups have more learning opportunity than bigger companies. Again, of course, joining a bigger company would be definitely good because they have a established process and established structure. Startup is kind of a thing which is a little bit flexible, but there are tons of opportunities available, particularly if you look at the design part. There are emerging design companies. I have seen E-Infochip hiring. I have seen Texas Instrument hiring. I have seen Cadence. If you look at the Cadence and Synapse, they are also giving opportunity to do internship with them. There are companies like Incor Semi, Chip Spirit, Indisamic, VSD Squadron. A lot of companies are there who would offer really nice internship where you can actually become industry ready designers.
Like I would also like to give my one uh, inputs to this. Like many IITs have their own incubation sector section, like IIT Delhi have FITT Delhi. Like yes, so they all are incubating VLSI startups. So we can contact all those startups on LinkedIn, and we can ask them if they have any working opportunities or not, because I see students only applying to MNCs and they don't get job because they are asking for work experience. So this is also a way in which we can get into the industry.
Right, right. Of course, yes.
So what is the one piece of advice you wish you had received when you were starting in the semiconductor field?
Even this answer will also cover Zubair's question, which he put in chat. So basically, right, if I have received, good advice would be some tips and some tricks which I can move directly to my results. But I had to, go through the rough path where I have to, implement some things, and I got failed, and then I learned, and then I re engage into different way of doing that thing, and then eventually I get success. So the iteration and the ability to jump start again and re-engage yourself is really important. And focus, what Zubair asked, is focus is also very important. Maybe I can say that whenever I sleep I see wafers and chips being manufactured. But like, of course, there should be, like, if you like chip designing, then the struggles and hurdles won't bother you at all. If
Yes,
you
very
really
true. We
like
should
that.
love what we are doing.
Exactly. So I love making chips. So I never felt that I'm heavily stressed or anything. The stress comes from other task management. So as I told you, like, you need to have task management and time management skill. And when you are in high pressure, you of course take some break. If you're highly pressurized, take some break, then start it
Yes.
again. Taking break never ever going to take your focus on, because if you like things, you take break, then you can
Yes.
easily start back again on what you're doing.
Like you talked about IPs, so how can we search for IP projects which can later be converted to startups?
So there are like a lot many IP libraries available. If you look at our eFabless GitHub repository, we have people submitted 649, 648 or 649 projects, and some of them IPs are available. Of course, I don't suggest just copy it, just use them as a reference and create your own IPs. But you can check a lot of projects already submitted. Based on that, you can identify what kind of IPs you can make. For example, you can create your own encryption core, you can create your own peripheral. So basically, a lot of people, create like I2C to UART and UART to USB converter IPs and all that. But you can identify that, yeah, PCIe and USB converter is also required. PCIe and encryption is also required. PCIe and wishbone connection is also required. So that way you can create your own IP as well for peripherals. You can also create your IPs like as a small block of the project. So, for example, you create a small tile of convolution and a deep neural network, and you can sell this IP to a company who is making NPU SoC. So that way you can the use cases are in large numbers. You can do lot many things in that segment for them. It will take like 2-3 hours just to discuss these things.
So, how do you see the semiconductor and VLSI industry evolving, and what role can the next generation of engineers and entrepreneurs play in shaping this future?
I suggest that everyone should learn AI as a basic. I don't tell you that you become an AI expert from the beginning, but utilize that because looking towards the industry, it will require chip designers and circuit designers with AI abilities. Like AI friendly coding, AI friendly documentation, AI friendly tool utilization, AI friendly team management, everything. So you need to learn AI as well. I also suggest that you guys create some small groups and do some share knowledge sharing, because industry is going in direction where you require multitasking, as well as you need to have knowledge of multiple industries, and everything won't come from just reading. You will require others help. So I suggest that create small groups, share some knowledge, uh, create a lot of WhatsApp groups, share the good research papers, good links that will help grow everyone together. Right? We elevate ourselves to a level so we can become like very industry ready and deployable engineers in the system.
Like, what kind of AI to learn? AI, like one AI is to learn the mathematics behind that, or you are talking only about the generative AI here?
No, no. I suggest that you learn some algorithms. Of course, generative AI you can learn for your own self learning thing that it will help you out with a lot other tasks. But you need to learn AI because each and every projects and user applications will have AI into it. We are going to have some our washing machines and refrigerator and ovens being smart. So like there are a lot of things you need to learn, like SLM, small language modules. So large language modules you are already being learning, but SLM is really nice. Particularly chip designer must learn SLM as well as like the edge chips, which will require edge AI system where you create a system smart, not genius but smart. So that is, must have a skill in this era for sure.
Like, we have also created our communities. So, like you said, that we should make one group. Like, we already have one group. So,
Wonderful.
so as we come to the end of this insightful conversation, I would like to thank our guest for sharing such a valuable knowledge and experiences in the semiconductor and VLSI landscape. So, your journey from building a foundry to navigating the complexities of entrepreneurship has certainly provided a lot of inspiration and direction for students and innovators. And thank you for tuning in today's episode. Be sure to follow us for more insightful conversation like this, where we explore the crossroads roads of technology, innovation, and entrepreneurship. And in our next session, we are going to have a podcast with the RISC-V advocate. So he is working at RISC-V International. So next week we will learn about RISC-V in more detail. Okay, thank you so much.